These are the lesson 4.3 notes on graphing proportional relationships. Our key idea is direct variation, that when two quantities, x and y, are proportional, the relationship can be represented by the direct variation equation y equals mx, where m is the constant of proportionality. You know that m is the slope, so this is just another name for the slope, is the constant of proportionality when it is in a proportional relationship. Okay, not all slopes are the constant of proportionality. I also want to draw your attention to the fact that we're talking about two quantities, x and y, being proportional. We're not talking about two lines being proportional. There was some confusion last year when we graphed lines and you saw two parallel lines and you said, well, those have the same slope, so they must be proportional. Uh, Quantities are proportional, not lines. Okay. The other big idea here is that the graph of y equals mx is a line with a slope of m that passes through the origin. Okay, that's essential. So the equation of a line that is proportional is y equals mx, and there's no plus b on the end. There's no y-intercept. The y-intercept is 0. So let's see what that looks like. The cost, y, in dollars for x gigabytes of data on an internet plan is represented by y equals 10x. We're going to graph the equation and interpret the slope. I'm going to come back to this idea a lot. To interpret means to tell what it means in the context of the problem. Telling me what the slope is not the same as telling me what it means in the context of the problem. Okay, so we'll come back to this idea. Okay, so to start this, let's just kind of write down what we know. We know that for every 1 gigabyte, the cost goes up $10. That's interpreting the slope. Let's make a little chart here. I guess we should do some graphing too, huh? X and Y. And then you have your ordered pair. All right. So the Y value is the cost. It tells you in the problem that the Y is going to be cost in dollars. And it tells you in the problem that X is gigabytes. All right. And let's substitute in some values so that we can see how to number our coordinate plane. Let's see, let's choose. It's always good to have the choose 0 as your x coordinate so that you can find the y-intercept. So if I substitute 0 into the, let's see, what will I write it? Y equals 10x. So if I substitute in 0 for x, 10 times 0 is 0, so y is also 0. So now since I have this point 0, 0, does it tell us that it's proportional? The cost is represented. Okay, so we're going to, now we realize that it's proportional. Then let's choose some more values. If x is 1, Substitute 1 in. 10 times 1 is 10. And then maybe jump out just a little bit so we get a little bit more spread there. When you substitute in 4, we're going to get 40. Okay, so let's number our gigabytes, maybe by ones, because they're going up pretty fast, because the Y values are going up fast. And let's count our Y values by tens. Okay, on there. And what else? I'll come back to the slope. All right, let's just go ahead and graph first. So we've got 0, 0 on there, then over 1, up 10, over 4, and up to 40. Okay, so I graphed it. One other thing I want to pull out is finding the slope. The slope is the change in the Y value over the change in the X value. And you can do that from the chart, where you can say, let's do it from the chart and from the graph so we can see that it's the same thing. The change in the Y value, if it goes up from 0 to 10, is 10. And from 0 to 1, the X is going up by 1. So the slope is 10. You can also see it here in your graph, and we could even choose, if you don't want to work with that little bitty square, you can even choose a bigger space like that. What you have to be careful about if you do that, though, is to remember that you're looking at a different scale on the Y as from on the X. So the change in the Y here is 20 over the change in the X, which is 2. And 20 over 2 is also 10. Okay. You have a similar problem. What if the cost is represented by Y equals 12x? Now graph that and interpret the slope. And just want to pull back to the idea that interpreting the slope is telling what it means in the context of the problem. In the context of this problem, the slope, which is 10, is the cost for 1 gigabyte of data. Okay. I'm not loving my purple pen. I'm going to switch to Skippy. Okay, so the next problem says that the weight of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. This is where the problems start to get interesting, is reading that data and figuring out from that data what you know and what you can figure out in order to write a problem. So it tells us, we are given, that it is proportional. Okay, so if it's proportional, then the equation that you're going to write is going to be in the form y equals mx. All right, so these are the things that you have to look for. And we can find out, we also have a point. They give us a point. A point is an xy, right? And they tell us that x is the weight on Earth, and that y is the weight on Titan. And then they tell us some information there, right? So on Earth, it weighs 105 pounds. So we have a point, 105, 15. Okay, so there's part of the data. So now I can substitute in 15 for y and 105 for x, but I still need to know the slope, right? Let's see. All right, so I can find my slope. All right, there are lots of ways to find a slope. So far, we've looked at if I have 2 points, then I can subtract them, and I can find the change in the y and the change in the x, and that will give me a slope. But this time, I don't have 2 points. I only have 1 point, xy, or I guess you do have another slope because you know that since it's proportional, it's going to go through 0, 0. So you could do it that way. You could do change in y and change in x and find your slope that way. Or you can substitute in to your equation. Y is equal to 15. And m is what we're solving for. And x is 105. And that looks a little backwards, doesn't it? We're going to divide both sides by 105 so that we can get the m by itself. That'll cancel out. And so you've got m equals 15 over 105. And those are both divisible by 15. So you end up with 1 over 7. You do not want this to be a decimal answer, all right? Keep your slope as a fraction, because what this fraction tells you is that I'm going to go up 1 and over 7 if I'm graphing. It's a change in the y value, up, over, up, over, up, over. And that's hard to do with a decimal, right? So leave it like that. So then your formula or your equation is y equals 1/7 x. Let's see what that would look like if we did m, if we did another point. 0, 0, which we know because it's proportional. I can do the change in the y over change in x. These y values change from 15 to 0, depending on which direction you're going. 15 to 0 is negative 15. And from 105 to 0 is negative 105. And then when you subtract through, or sorry, divide through, you get 1/7. So you could get it either way. All right. Similar problem. Oh, no. Continuing on the problem. So we've got y equals 1/7 x. So now you're going to use it. How much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? So go back to, let's see, Titan is the y values. I'm going to put the 3.5 in for y equals 1/7, and x is what we're solving for. Oh, how do I solve for x? I need to multiply by the reciprocal. Right, and that'll all cancel out. And you're left with x equals 7 times 3.5, which is 24.5. That's pounds. Okay. And then you have a UTRI, which is similar. A spacecraft that weighs 3,500 kilograms on Earth weighs what on Titan? Okay. All right, and then we have these sorts of problems where they will give you one piece of data in a chart, or sorry, in a graph, and they'll give you another piece of data in an equation, and then they will ask you to compare those two. Okay. The distance, y, in meters, this tells you what that is, that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5x. So this is the 4-person. And then the 2-person is here in the graph. All right, so they are both showing you meters per second. Remember that per means divided, so it's the change in the y meters per the change in the x seconds. All right, and we are trying to find out which ski lift is faster. Okay, so I'm going to pull down that this slope so interpreting that slope, the slope means we're going 2.5 meters per 1 second. All right. The y value changes 2.5 every time the x value changes 1. All right. And the slope of the two-person, let's do change in y over change in x, and you can get that from the graph. So the y values, it's going up. It's changing from 4 to 12, so that's a change of 8. And the x values change from 2 to 6, so that's 4. So the two-person is going 2 meters per second. Okay, so the four-person is faster because it's going 2.5. Get everything there. I'm going to add on that the slope is the speed. Okay, we got that. Speed is the distance divided by the seconds. It's a lot of information there, just a lot of connections to make. That slope is a rate. That's a really big idea, that slopes are rates. So we're finding the change in the y value over the change in the x value gives you a rate. Speed is a rate. It's a distance divided by a time. Right, so you can think about that lots of different ways that are all correct and all kind of tie together. So now we're going to graph the equation that represents the four-person lift in the same coordinate plane as the two-person lift, and then compare the steepness of the graph. What do you think that's going to look like? When you put them both in the same picture, what do you think it's going to look like? Is one going to be steeper than the other? Which one should be steeper? So we're going to do a similar graph. We're going to do distance in meters on the y. And we're going to do speed in seconds on x. No, that is not correct. We're not doing speed. We're doing time, because speed is the slope, it's the rate. Sorry about that. All right. And then let's number by ones. I don't know how far up to go. Okay. And then we'll also count by ones on the work. Okay. Okay. And I'm going to do, let's do the two-person in my pink pen. And then we'll do the four-person in the blue pen. Okay, the two-person expression was y equals the slope of 2x, so slope of 2. And so let's just substitute in some points. We know that we're going to start at 0. This 2, the change in y over the change in x is 2 over 1. So that means I'm going to go up 2 over 1. So I'm going to start here at 0, and I'm going to go up 2, 1, 2, and over 1. Up 2, over 1. Up 2, over 1. That's how you graph an equation. You find the y-intercept, which since this is proportional, is here at 0, and then you use the slope. And you go up the amount of the y and over the amount of the x, and up the amount of the y and over the amount of the x. Isn't that handy? That's how you do it. And then after you get a few lines drawn, you can draw that. Okay, and then switch colors. The 4-person was going up 2.5 meters per second. So we're going to go up 2.5 and over 1. So starting in the same place, we're going to go up 2.5, over 1, 2, over 1, up 2.5, and over 1. Okay, so we're starting in the same place. All right. And so what we should see when we graph is that the bigger slope, the steeper slope, makes a steeper line. It is closer to the y, right? It's steeper. It's closer to the y-axis. This is a less steep slope, so it's closer to the x-axis. All right, and then you have one you try, which at first glance looks terrible because it has fractions in it, but the fractions are easy. Okay, so you're just going to do the same thing. You're going to take this line and compare it, this T-bar ski lift, and compare it to the ski lifts in example 3. So if you want to, you can do some work here and then graph it on the same coordinate plane. I would graph it on the same graph so that you can see where it falls. So is it steeper? Is it below? Or is it right in the middle?